in general, if you have a system of linear inequalities that you're graphing, you got to think about a couple things, right? Whether the line should be dashed, dotted, solid, whatever you want to call it, dashed or solid. And you got to think whether you're going to shade above or below each line. And so each system here, I do have an example that has 3 equations. So when you have a system of inequalities, you got to think about those things just for generally graphing an inequality. But then, if you have a system, right, the shaded area satisfies all inequalities in the system. And usually on a graph, like it's basically like where the shading would overlap. So all the points that would be in this shaded area would work for both inequalities, or maybe you have 3 inequalities in the system. It's going to depend on the question. So I'm going to show you how I usually do it. And then if you guys like that, or sometimes people like to shade both and then darken in the overlap or whatever. So that's up to you how you want to do that. But I'm going to show you kind of how I go through one of these. So I just do one at a time. So I've got y is greater than negative x minus 1. So I immediately say, okay, no, that's, fail. Let me get you guys some rulers just in case you want some today. They're graphing these lines. I should have passed those out. Tired. Okay. I'll just grab a little ruler here. You guys don't have to use these or anything, but might as well. Oh, you're good. Just go ahead. Okay. Guys, you're awful noisy today. All right. Now, I'm going to draw a dotted line. I'm going to use my ruler to help me on this. And I'm greater than shaded above if you're doing greater than. Okay, so I'm just going to find negative 1. My slope is also negative 1. So I'm going to go down 1 over 1, down 1 over 1. And I'm going to really try to remind myself that I should be doing a dashed line. And I'm just going to use this lovely little ruler just to help me kind of put that together a little bit. Okay, now this is totally up to you. Maybe I will just lightly, this is greater than, so I'm just going to make a little tiny note that I would shade above that line. But I'm not going to really shade it. Now, I'm going to grab a different color on my paper. So, this other one is not in slope-intercept form. You could do intercepts here, but 2 doesn't divide into 9 nicely. So maybe what I would do is actually solve this second inequality for y. Just get y by itself on one side, put it in slope-intercept form, might make it a little easier to work with. So I'm going to have negative 3y is greater than, and I'm just going to, bless you, write the negative 2x right after the inequality symbol. That 9 is positive, so I'm just going to kind of slide that to the side and write plus 9. And I'm going to divide everybody by negative 3. If I divide everybody by negative 3 in an inequality, what do I have to do? What do we have to do if you divide by a negative? Okay, good. I had her flip the sign. Do not forget to do that because that'll change your shading, okay? So this is going to become y is less than. Now, negative 2 divided by negative 3 would turn that into positive 2/3. I'll just pull the x to the side. That's your slope. And then 9 divided by negative 3 is minus 3. Now, once I'm here, this one will also be a dashed or dotted line. But because we flipped the inequality symbol, I'm going to shade below that dashed line. So find negative 3, and then I'm going to go up 2 over 3 to the right. And I'm just going to do a couple, and I'm going to grab my little ruler and make this a dotted or dashed line. Okay, now lightly I'm going to shade below that line. Now, the actual area that works for both, because the system, any point that I choose here that, bless you, would be a solution to the system has to work, bless you, work for both. We got to look for where they overlap. So I'm above this first line, but below the second line at the same time. Can you guys kind of see it should be, this is an overlap where I did both. So bigger than the first line, but smaller than the second line. Now, do points on either of these lines satisfy the system? No. Because? They're dashed. Exactly. Perfect. No, they're dashed. Okay. So if I say to you, could you give me an example of a solution to this system? What would you look for to tell me that? Or what could be an example of that? Exactly. We could all have a different answer to this question that would be correct. And I mean, this graph could be bigger than the window that I've got on the picture here. But literally any point that would fall in that shaded area. So just any point you want. Just grab a point. I don't know. I'm going to grab, as an example, I just put a dot on 8, -3 on mine. But literally any point that would fall in that shaded region should work for both of those inequalities. That's all you have to do. Is anybody having a question? Okay, let's try this one. Should I have, if I've got y greater than or equal to 1/2 x, -1/2 x, -4, am I going to have a solid line or a dashed line? Solid, for sure. Okay, are you going to shade above or below? If it's greater than or equal to. Above or below? Yeah, above. You guys can talk. It's okay. Above. All right, so let's start at -4. All right, now I'm going to go down 1 over 2 to the right to use my rise over run. Down 1 over 2 to the right, and I'm going to make this guy a solid line when I play connect the dots. That means all the points on this line would be a solution to the system. And again, we could do intercepts, but on this second inequality they give us, 6 doesn't go into 10 nicely, so I might just go ahead and do what I did on that last question and put this in slope-intercept form just by subtracting 6x real quick. And so I'd have 2y is less than -6x. I'm just going to slide the 10 down a little bit, divide everybody by 2. Am I going to flip the inequality symbol over? No. No, we're just dividing by +2. So this is going to say y is less than, this would be -3x as my slope, and then my x, and then +5. This guy dashed line, and I'm going to shade below that dashed line. So I'm going to find 5, and then I'm going to go down 3, but just over 1. And this will be really steep, so sometimes that's a little bit tricky to graph. And then I'm going to do my best to do a dashed line. Now, all the points on this line are not part of the solution because it's not equal to, it's dashed. So if you told me a point on that dashed line, it would not work. And fail, I forgot to do my shading. Okay, so on the first equation we graphed, we would shade above, so I'm just going to lightly just look at that. If I have the second line, that is less than. If you're ever not sure, and sometimes this one's really almost, it's not vertical, but it's a really steep slope. If I'm ever not sure, I just put your finger or your pen or your pencil, whatever, on. If you want to go below, just draw straight down, and that'll show you what side of that line you should be on. So it's kind of on the, below here is kind of on the left side of that line. What I'm looking for to work for both, so I'm greater than the one I did in my lovely pink, and I'm less than the one I did in my green. The overlap should be in here. All these points. If we plug them in for x and y, they work for both inequalities. Could anybody just raise your hand, just give me an example of a solution. What would be a solution to this system? Caroline, what do you think? Perfect, -2, 1. Everybody's could be different as long as it's in the shaded area. But a solution just means it's going to work for both, and it would be in the overlap shaded region that you've got on your graph there. Is anyone having a question? Okay, now my faves. All right, vertical and horizontal. So we're going to do a nice, remember these are messed up for people. I'm going to do a nice vertexal line. Now, your above and below do not work for a vertical line because you don't have an above a vertical line and a below the vertical line. So we're going to have to think about this for a second. All right, so I'm going to have a solid line at a vertical line of 2. So nice vertexal line. I'm not going to use the ruler here. I'm just going to freehand this. So all these x coordinates are 2. That first inequality says to me, I need my x-coordinate to be greater than or equal to 2. So where would you shade for just that first one? Liam, what do you think? Yes, so would that be right or left? Right. Perfect. Okay, these guys, all these x values are bigger than 2, right? All right, now my other inequality says x is less than -3, so ... because we have a dashed line here. Draw yourself a nice vertexal line where all the x values are -3. And which direction would you shade, left or right, if you want to be less than -3? Left. Yes. Okay. What would you tell me the solution to this system is? What do you think? There isn't. Those shaded parts don't overlap. There is no way you can have an x-coordinate bigger than 2 and an x-coordinate less than -3 at the same time. You might be able to read the system and just know that without graphing it, but just to say that there's no possible way that my x-coordinate can be 2 or bigger and -3 and smaller than -3 at the same time. So the shading does not overlap. If that happens, you don't have a solution. Okay, now if we have a plane y and a plane number, that's going to be a nice horizontal line. So this will work for your above and below. Dashed line, nice horizontal line at 5. And less than, we're going to go below for that one. So I'm just going to lightly shade down here. Now, what is another name for the line x equals 0? On a graph. What do you think? The y-axis. Okay, always messes people up because it's x, but it's actually the y-axis. All right, so x equals 0 here. This would be a solid line. I'm going to be greater than or equal to 0 for my x-coordinate. So it would just go solid line down the y-axis. All these points would be part of the solution. Okay, greater than goes to the right. So we'll go this way. All these x values are greater than or equal to 0. Now this is going to look like a quadrant when you shade the overlap. All these points have a y-coordinate smaller than 5, but an x-coordinate bigger than 0. Now at the very bottom, just right here, is 0, 5 a solution? This is a really tricky question. Is 0, 5, is that point, let me identify it here, right here. Is that point a solution to this system? Because exactly, this is really tricky. So that's actually the intersection of these two lines, right? Because this is dashed and this is solid. It works for the solid line, but it does not work for the dashed line. So if you had to defend that or something, the y-coordinate cannot be equal to 5. It's strictly less than 5. It's not equal to 5. So if I had to defend that point, it's like in the corner of the shaded area, but because one of the lines is dotted, it's not. If that was y is less than or equal to 5, then for sure that would be a correct answer. Is anybody having a question? Okay. Now, tiny throwback here to graphing absolute values, but we're going to graph an absolute value inequality. So automatically, if you see those absolute value bars, I want you to think of a V shape, right? And then we're going to manipulate these lovely V shapes. But if you see those absolute value bars, we should be thinking about a V. Now, the first one is just greater than, so I'm going to use a dashed line, and it's greater than, so we're going to shade above. I'm going to kind of write this down here just a little bit so I can separate it from the system. Can anybody tell me, is that V going to go right side up or upside down? Upside down, right? Okay, the negative turns it upside down. Can anybody remember, just raise your hand and tell me, how do I find the here, it's because of this that it's going to go this direction. Okay, can anybody remember how to find the middle of the V? Like, what would the vertex be based on the equation? Jacob, what do you think? Yes, perfect. 2, 4. And with the x, it's the opposite of what it looks like. It's whatever would set that equal to 0. So 2, that switches from one side of the V to the other. Outside, you're just going to copy. That's your y coordinate. Now, I'm going to write this, and remember, technically one side is -1. But since I have just a little negative symbol, once I plot that point, you're just going to go down 1 over 1 on either side of that point. And we're going to remember to write a dotted or make a dotted line here. I'm in marker. If you're in pencil, you can erase, but I'm in marker, so I have to be really careful. Okay, so I'm just, from that vertex, I did 2, 4, and I just go down 1 over 1 on either side. And if you want to use a ruler, you can. If you don't, you don't. That's fine. Here's my lovely V shape, upside down V because of the negative there. Okay, now the shading here would be above, so I'm just gonna very lightly shade kind of above this, because really for our system I need the overlap of both of these absolute values, so I'll just lightly shade that. Okay, now the other one, I have y is less than or equal to 2 times x plus 1 minus 7. So that less than or equal to, if you see it, it's solid. So I see the equal sign underlining that inequality symbol. So it's a solid line. And less than, we're going to shade below. Okay. Can anybody tell me, is this V going to go right side up or upside down? What do you think? Right side up. This is just a positive 2. It'll just be kind of more narrow than the one we just did because that 2 will affect the slope, but it should go up because that's positive. Can anybody raise your hand and tell me what the vertex of the second inequality would be? Liam, what do you think? Excellent. -1, -7, opposite copy. Okay, now, because you have that 2 out in front, I'm just going to kind of, again, write this in quotation marks, because technically one side will be 2 and one side will be -2 if we actually did the slope correctly. But the slope is going to be just 2 over 1. So find your point there. So we have -1, -7. It's really close to the bottom of the graph. From there, on either side, just go up 2 and over 1. And then I'm just going to repeat that. Now this one's going to be solid, so I'll go ahead. Let me just use my ruler to help me here. And I'm going to connect the dots with a solid line there. And a solid line here. Okay, now this one is kind of weird. So I am supposed to be below this line, or this V shape here. So it'd be like underneath. Okay, the overlap is super weird. There's actually 2 different regions if you did this correctly. So above the pink one on mine, below the green one here. And you can have this where you might have 2 different regions that would satisfy your system. So if there's a piece here that's overlapped, there's also a piece over here where I'm above the pink line but below the green line. So there's like an overlap in 2 different places. So there's 2 different regions of this graph that would satisfy those 2 inequalities. And I know that's kind of weird, so that's why I wanted to show you guys that. That can happen. That won't happen if you have 2 lines, but if you have an absolute value or maybe a different type shape of a graph, that can happen. Is anyone having a question? Okay, now, the day would not be complete without an evil story problem, so here we go. All right, it says Adam and his children went to a restaurant where they sell hot dogs for $3 each and tacos for $4 each, and he has $60 to spend. Those 3 pieces of information are going to go together. Money goes with money. All right, he has to buy at least 12 hot dogs and tacos all together, so that goes together. and he can't buy, this actually has 3 different inequalities we're going to graph. He can't buy more than 10 hot dogs. Okay, just so we all have the same graph, really you could use either variable to represent either one, but just so we all have the same graph, underneath here I just said X is going to represent the hot dogs and Y is going to represent the tacos. Right, and solve the system of inequalities. Okay, can anybody tell me, I've got hot dogs are $3 a piece, tacos are $4 a piece, I got $60 to spend, so he only has $60 in his wallet. How could I write an inequality to represent just the money part? Go ahead. So, he has $60 in his wallet. So like what he spends would be over here. Then less than or equal to. Yeah, so what he spends would be on the left side of that. Okay, now what I would tell you here, I would just use intercepts on this particular question because 60 is divisible by both of those numbers. What is 60 divided by 3? 20. So on your x-axis, you'd be at 20. That means you bought 20 hot dogs and you spent all $60. That's what that point would mean. Okay, does anybody know what 60 divided by 4 is? 15. Okay, so that would be your y-intercept. And that would mean I bought all tacos and spent all $60. Now, I'm going to play connect the dots here. And I'm not going to shade right now, but the shading would be below that line, like just into the first quadrant. We're not going to go out of the first quadrant because you can't buy a negative number of hot dogs or a negative number of tacos. All right, now it says altogether I have to buy at least 12 items, right? So I'm going to buy 12 hot dogs and tacos together. How could I write that as an inequality? Exactly right. X plus Y greater than or equal to 12. So number of tacos plus number of hot dogs at least means what I'm buying, which would be the X plus Y, has to be greater than or equal to 12. Okay, super easy to do intercepts on this. You just have X would be 12 and Y would be 12. So just 12 and 12. And I'm going to use my little ruler again here, play connect the dots. Okay, now in terms of the shading here, that shading would be above, right? Because I need to buy at least 12 items. So in this moment right here, before our last little requirement, we would be between these two inequalities on the graph. So between these two lines. Okay, now the last thing just says he can't buy any more than 10 hot dogs. How would I write that as an inequality? I cannot buy any more than 10. Autumn, what do you think? Exactly. X is not even involving the taco at all. X is less than or equal to 10. So you're just going to have a nice vertical line. I'm going to go ahead and use my ruler again at 10. Okay, now I have to be less than. So would you go right or left with that vertical line? Left. Left. Less than goes to the left. Okay, now I'm between the two lines, right, to start out, and then I'm going to be to the left of this vertical line that we just drew. So the overlap would be in here. All those would represent possible combinations we could get of hot dogs and tacos that would fulfill all the requirements that we just set out in front of us. So if you want to do a possible solution, literally just grab any point. I'm just going to grab a point here in the shaded region, and I'm going to grab the point 6, 8, which would mean I bought 6 hot dogs and 8 tacos, but I stayed within my budget and I met my requirements for the amount of food that I needed to get. Just as an example. Is anybody having a question?